Welcome to 2021, the year we are finally taking climate change seriously. Hi, I'm John Brockup. I'm professor of history, religious studies, and philosophy at Penn State, and I'm super excited about the climate summit that recently took place in Washington, D.C., and you should be too. In this very short video, I want to tell you a bit about why I'm so excited and what this is going to mean for Pennsylvania. This is not a video about the science of climate change. If you're interested in that, I've got one of those. It's not a video about the ethics of climate change or international negotiations. I have videos on that as well on my YouTube channel. This is a video that focuses directly on what's going to happen here in Pennsylvania in the next 10 years. So in this video, I want to talk about what a 50% reduction by 2030 actually means, to get a little bit geeky here and dive into the numbers, and then go through Pennsylvania's carbon footprint to understand how we can get to this 50% reduction in just a few short years, and then speculate a bit on where we go from there. So let's understand what the challenge exactly is. It's a 50% reduction of greenhouse gases over 2005 levels. Now, all the numbers I'm getting here are from Pennsylvania's own carbon assessment, which was done in 2020. Most of these numbers are based actually on 2017, which is the last time we have reliable statistics. So in 2005, Pennsylvania was emitting 287 million megatons carbon dioxide equivalents. So this is including all kinds of greenhouse gases, including carbon dioxide and methane, and it's translated into what are called carbon dioxide equivalents. So we have a clear number to work with. Half of 287, half of the 2005 level, is 143. But we're not starting at 287. We've already reduced our greenhouse gases since 2005. We're actually now at 233. So what we need to do to get to 143 is to find 90.5 million megatons carbon dioxide equivalent. So that's what we have to do. That's our challenge. Where are we going to find that kind of amount of greenhouse gases? First thing I want to do is emphasize this is absolutely doable, because we have already done it. We've already started to cut our greenhouse gases, and we can do more. Plus, I happen to work at Penn State, and I'm very proud of my university and the fact that it's already cut its greenhouse gas emissions 50% over 2005 levels. Almost nobody knows this, because this has been done virtually entirely by the Office of Physical Plant, behind the scenes. Also, Penn State has actually increased its square footage of teaching and lab space and lecture space, all that while reducing its greenhouse gases. You see that back in 2005, we were well above 600,000 tons of carbon, and now we're at half that point. So this is Penn State system-wide, all the Commonwealth campuses plus University Park. And you can see that this reduction is real and has been accounted for. So Penn State knows how to do it, and I'm going to build on that expertise in making my suggestions today. There are many pathways to get to this 50% challenge, but quitting coal alone would do almost all of it. And I want to lay out how that's possible. The rest should be done by conservation, which, as I'll explain, is actually how Penn State has found most of its reductions, through conservation of energy. Now, if we go through Pennsylvania greenhouse gases, we can split them up into sectors. And again, this is the official government report. We find that residential only accounts for about 7% of greenhouse gases produced in Pennsylvania. So while it's really important, and I urge you to change your light bulbs and add insulation and do all kinds of good things to reduce your carbon footprint at home, in fact, this is a small percentage of the greenhouse gases in total produced in this state. Commercial likewise, and by commercial buildings, I'm referring to stores and offices. This is likewise only a small percentage of the greenhouse gas production. The majority comes from three areas. First of all, transportation, which accounts for a quarter of our greenhouse gases in this state. Electricity production accounts for almost a third of greenhouse gases, and industrial. So these are the three areas that we must look at if we're going to look for a quick, effective change in our greenhouse gas production. You can see it here in this chart. It shows you that these three areas cover more than 3/4 of emissions, with the rest then covered by these smaller sectors. Of course, it's important we work on all of these. I'm not saying that we shouldn't. It's just if we need to look for the biggest bang for our buck, we start with these big areas. Let's take electricity production and break it down for a minute. Nearly half of electricity production in Pennsylvania is now through the burning of natural gas. Natural gas running turbines then that produce electricity. And over a third is produced by nuclear. Coal only accounts for 16.5% of electricity production. This is a huge change in Pennsylvania since 2005. So we have already moved off of coal in terms of electricity production significantly since 2005. In fact, that's where we've gotten most of our savings in terms of greenhouse gas productions. There are only 18 coal-fired electricity power plants left statewide. However, these power plants account for 61% of greenhouse gases in this sector. Altogether, that's 46 million metric tons carbon dioxide equivalent. And then if we add coal mining to that, which fits in the industrial sector, that adds 10 more million metric tons. So how do we find this 90 million metric tons by 2030? Well, again, if we just take 46 from coal-fired electrical power plants, of course, this will take time to shut these down. We should retire the dirtiest plants first. We must take account of the fact that these workers need to be retrained. So this is a process. It will take some years to undertake. But with this and with replacing that electricity through solar and wind, which by the way are much cheaper to build now than new power plants, even those fired by natural gas, we will have the benefits of lowering our carbon footprint, of having cleaner air, because coal not only burns very dirty in terms of producing lots of greenhouse gases, it also leaves lots of other residuals in the atmosphere, which cause asthma and cancer, and even things like lead in the atmosphere are from coal-fired power plants. So reducing our dependence on coal will have multiple benefits, but we're focusing right now on the 46 million megatons of carbon dioxide that would be taken out from this process. Again, if we look at coal mining and remove that as well, we've got the whole process of coal mining uses a lot of energy, and so it would mean another savings of 10 million megatons of carbon dioxide. Some of this comes from abandoned coal mines that are on fire and are producing greenhouse gases in this process. So we want to shut down those fires, to shut down this coal mining operation. And in this process, we sell a lot of our coal elsewhere. We export it overseas. And we are also going to be reducing the greenhouse gases of those states and countries and places that burn our coal. So in this, we have, again, a double positive effect in reducing our greenhouse gases by no longer undertaking these mining operations, and also removing our responsibility for sending that coal overseas and increasing greenhouse gases in other countries. So we've got this multiple benefit by stopping the use of coal. Where do we get the rest of this 90 million megatons? Well, my suggestion is that we turn first to conservation of energy. Now, conservation means two things. On the one hand, conservation is simply using less. For example, I can turn out my lights here, and it's a little harder to see me. It's not so bad, but I'm using less electricity. And in that process, of course, because electricity right now is being produced at least partly by coal and natural gas, I'm reducing my use of greenhouse gases. So using less, then we turn off lights, we certainly add insulation. But what we see when we learn from Penn State University is it's this process they call continuous commissioning, where they are going through all of their buildings and constantly looking at the building envelope, non-sexy things like caulking spaces that are letting in cold air, but also adding insulation to pipes and upgrading systems so that they're more efficient. If you look at what are called wedges, as Penn State has imagined that from 2005, its use of energy would actually go up as it increases space and as has been the trend in the past. So it adds these wedges which account for the reduction in greenhouse gases which they have seen. There are various wedges that here are important. This orange one is interesting because this was the conversion of one of the power plants from coal to natural gas, adding a CHP plant, a combined heat and power plant. So it basically doubles the efficiency of burning that fossil fuel. So you're getting twice as much bang for the buck. And that's the second part of conservation. So one is using less, and the other is using your energy more efficiently. Changing lighting is another example of using energy more efficiently, because modern lights made from LEDs actually emit the same amount of light for about 1/8 the energy of an incandescent light bulb. So just by switching your light to an LED, you'll notice that LED lights are not, they do not produce any heat. You can touch them. I've got one right here. You can put your hand right on it, no problem. Whereas you can't touch an incandescent light bulb. It's burning hot and it's wasting a lot of energy through the production of heat. So through these two things, and there are many, many other examples of ways that we can conserve energy by using less and by using it more efficiently. When we go through all of our different sectors and have more efficient cars and trucks, more efficient industrial processes, more efficient uses of energy in homes and businesses, I think we can get this 34 million metric tons fairly easily. So once we start with this process and get to our goal of half of 2005 levels by 2030, where do we go from there? Because in fact, the challenge of climate change is that we must get to carbon neutrality. We must get to effectively zero carbon emissions. If you're interested in how one does this at a home, I've got a video showing you my rental property and the way that I've changed that into a virtually carbon neutral residence. So it is possible. And what we'll have in the result is a cleaner and more efficient world. Right now, solar and wind prices are at parity or below. That means that it's cheaper now to build a new solar or a new wind farm as compared to building a new gas-fired electrical power plant. Those prices will continue to fall, and it'll become even more advantageous to have this new, cheaper energy. If we had carbon pricing, that would level the playing field. One of the most exciting parts of the discussions happening at this climate summit is a real foray into worldwide carbon pricing. So not piecemeal, one state against another, but rather the entire world agreeing on a floor price for carbon pricing. What carbon pricing is then is each state, each individual country would establish its own method of doing this. There are a variety of vehicles. The one piece of legislation in front of Congress right now is called a carbon fee and dividend that takes that tax on carbon and returns it to poorer people, people who have less means, and for whom the higher rate of gas prices, for example, might be a burden. So it's called a revenue neutral bill. So that's one way of doing it. Another is Pennsylvania joining the Regional Greenhouse Gas Initiative, or RGGI, here in the Northeast. There are quite a variety of ways of doing carbon pricing. And the net result is it makes innovation in new energy much more possible. So with this drive towards innovation, what we're going to see beyond 2030 is increasing attention to carbon sequestration, carbon capture, and reuse. So this is a process of capturing the carbon from tailpipe emissions, from smokestack emissions, and either storing it back into the ground or converting it to fuel or food. Now, there are Penn State researchers and researchers at many universities working on this, and there are already some carbon capture plants in operation right now. We can also capture methane as it's being produced from farms and cesspools and landfills. And this methane is the major element of natural gas, and it can be used then to make electricity, to heat homes, to provide us with all kinds of, in fact, carbon neutral sources of energy. Likewise, from waste products, we can make hydrogen using bacteria. There are many, many examples of these sorts of innovations that are now in the pipeline. This is the new world we're looking at, and the exciting part is that we are going to see this change in our lifetimes, moving away from fossil fuels, which is literally burning fossils, burning energy that was sequestered by plants hundreds of millions of years ago, and turning toward a sustainable energy system where we are using the energy that's provided to us by the sun, by the wind and natural processes, and that will carry us and carry our children and the next generations into a cleaner future.